Hey guys, welcome to another Mr. Dart Maths video. Today we're going to be talking about radians. Now, in maths you'll often see radians used instead of degrees, so what we need to talk about is what is a radian and how it is defined. So 1 radian, or 1 rad, you might see this little C next to some signs, is the angle that is formed by an arc being the small section of an outside of a circle that is equal in length to the radius. So you have the radius and then an arc that is also a radius large, and that angle that is formed in that arc is a radian. Okay? Usually you don't need to write the little c. It depends on context. For degrees you should always write it. Radians, it's pretty flexible. Alright. Now, if 1 radian is 1 radius of the circumference, and our circumference is 2 pi lots of the radius, meaning that there's 2 pi of the radius completely around, so you got until you have 2 pi lots of the radius, then remember that 1 radian, 1 radius, 2 pi radiuses means 2 pi radians in a full revolution. Got a little diagram that might help you to visualize that a little bit better. So there's your radius, there's your circle. Once you have this arc of the same length, then you have your 1 radian in the middle there. Go around a few times. I'll keep adding on radiuses, same length here, radius, and then you have pi radians for half a circle, or 2 pi radians for a full circle. Okay, which makes the full circumference. So we have 2 pi radians, or 360 degrees. It is 360 degrees. Or you could say pi radians is 180, or 1 radian is 180 on pi degrees. So this is our conversion factor, being able to go from radians to degrees, or from degrees to radians. And I've done a little table here for you. To go from radians to degrees, you're multiplying by 180 and dividing by pi. That comes up sometimes, but mostly what we're going to be talking about is degrees to radians. We need to multiply by pi and divide by 180. Okay? Essentially, pi and 180 are the same thing, but depending on which direction you're going, you need to change if it's on the top or the bottom. Now, if you don't like this table, just writing it out like this might help you as well. Okay. So, let's talk about some common angles as radians, the ones that you're going to be seeing the most. Start with 30 degrees. If we're converting from radians, remember timesing by pi and dividing by 180, 30 over 180 is 1/6. Okay, there's 6 30s in 180, so we have pi on 6 radians. Now you can do the same thing with 60 degrees. You get pi on 3, 45 degrees, pi on 4, 90, pi on 2. These are the ones that you're going to be seeing the most. These denominators are the ones you're going to be seeing around a lot. Okay, so if you associate the denominator with the degrees, the multiple of degrees, you can usually do more. I'll usually do them a bit quicker. I'll demonstrate that in an example in a moment. Other ones that you're going to see a lot is 180, 270, and 360. Okay, 270 is 3 pi on 2, 180 is equal to pi, that's our conversion factor, and 2 pi for 360 degrees. A common mistake that I see every now and again is equating this pi on 3 as 30 degrees, or pi on 6 is 60. I'm pretty sure it's just because of the association between those numbers. 3 is 30, of course, right? But it is not. It's actually the other way around. So I want you to try and remember that this, the larger the denominator, then the smaller each piece is. So larger denominator, 6, means a smaller piece of the pie or circle. So those triangles that we've used before and the unit circle, you might need to start to associate some of those angles in those as radians. So we have the isosceles triangles that you may have seen in a previous video. So we have pi on 4 radians as the angle, or what would have been 45 degrees. That would have been 30 degrees, and this would have been 60 degrees. So we have pi on 3 radians and pi on 6 radians up in the top here. Unit circle, as you go around, remember that we're starting from the positive x-axis at 0 and then increasing 90 degrees, or pi on 2 radians. Keep going around, pi radians, 180 degrees, 3 pi on 2, 270, and then back until we've made a complete circle, which gets you the 2 pi radians. You're also going to need to probably change your calculator to radians, as that's what we're going to be working in a little bit. Let's try some examples. So I'm going to try and demonstrate the way that I think through these problems. Find exact values for the following. So the exact values are the ones that we've used in our previous table. They're the half, the 1 on root 2, the 1 on root 3, or root 3 for tan, the root 3 on 2, these kinds of things. So you might need to refer back to your table that we've gone through before. Okay, so cos of 11 pi on 6. On 6 means that we're talking about 30 degrees. We have 11 lots of pi on 6. So 11 lots of 30 degrees means that this is the same as 330 degrees. It's almost 2 pi. It's 1/6 off 2 pi. So it's 30 degrees off 360 degrees. Being in the fourth quadrant, okay, 330 degrees all the way around to there. Sorry, that's supposed to start from the x-axis there. But we have a 30-degree angle in there. Fourth quadrant, which is C. Remember that we've got A, S, T. C is the important one for this one. So cos of 30 degrees, and that's cos on 30 degrees. Let me just get this right. Should be root 3 on 2. So the more you do this, the quicker you'll be able to associate, and you'll be able to go from this first step straight to this last exact value, but maybe showing the thinking that you might be doing as you start off with these problems can help. So sine of 4 pi on 3, remember pi on 3 is 60 degrees, so we have 4 lots of 60 degrees. So you might think of this as sine of 240. Get my unit circle involved. 240 is about there. We're 60 degrees off of our x-axis. Alright, so this is t, means it's the same as negative sine of 60. Sine is negative in that fourth quadrant. And sine of 60 is also root 3 on 2. So we've got negative root 3 on 2 for sine 4 pi on 3. Okay. Tan of negative 3 pi on 4. Pi on 4 is 45 degrees, and we're going negative 3 lots of 45, which means we're going 135 degrees in a clockwise fashion. 135 degrees in a clockwise fashion, which means we're 45 degrees away from our x-axis. Tan is positive in the third quadrant, so it's the same as tan of 45, which should be 1. Okay. If you don't get fractions with the thirds, quarters, or sixths, or halves, you get kind of stranger values. Pi on 11 isn't really we don't have enough information to be able to do exact values from there. This is where we're going to be using our calculators. Okay, I'm going to make sure that my calculator is in radians up the top here. It's definitely in rads, and I'm just going to go sine of 1.03, 0.8, and we'll just go to 2 decimal places here, 0.86. Okay. Now we're doing cos of pi on 11. So trig cos pi on 11. All right, let's come up with an exact value. Let's assume that we want a decimal here, 0.96 to 2 decimal places. And there we go. Now, something that's a little bit more complicated, and we're going to look at the addition or difference of two angles a little bit later in another video. So you'll probably recognize this if you were to come back to this video after we do those. But for now, what we're going to do is we're going to split this into two problems. We're trying to show that sine of pi plus pi on 3 is equal to sine of pi times by cos of pi on 3 plus cos of pi and times by the sine of pi on 3. Okay. Start with the left-hand side. Let's think about sine of pi is equal to plus pi on 3. So let's go to our unit circle. If we're going pi, we've gone halfway around the circle, then pi on 3, yeah, a little bit past that x-axis, or pi on 3 radians past that x-axis. This is the same as 60 degrees, so keeping that in mind, we're in the third quadrant where only tan is positive, so this is the same as negative sine of pi on 3, or as an exact value, which is negative root 3 on 2. Let's consider our right-hand side now. We've got sine pi cos of pi on 3 cos of pi Alright, sine of pi, if we're halfway around, what's the y value at the edge of my circle here on this x-axis? Alright, well it's nothing, so what I actually see, this part goes to 0, which means all of that part does, because you're multiplying cos of pi on 3 by 0. So then we just need to worry about the left-hand side. Cos of pi, again, we are halfway around that axis, or to the negative side here. We're talking about the x value because it's cos. So how far are we in terms of our unit circle? We're at -1, 0. Cos of pi is -1, and sine of pi on 3, we've actually already done that. Okay, is √3 on 2. This time it's positive though, because we don't have the negative out the front, although cos is now negative, so both sides are negative √3 on 2. The left-hand side is equal to the right-hand side. So we've shown what we needed to show. Anyways, that's all the examples we have for now. Practice those exact values and those radians, and let me know if you have any questions.